All right, I took the Scantron forms over to scanning this morning. They usually have those back to me same day, so I'll have those results, and then I'll try to grade the pre-response sometime this weekend. And my goal is that we talk about it. It'll be posted. You know, your scores will be posted. I'll send an announcement out, and then we'll talk about it in class on Monday. All those things that we learned up till now, everything that we learned is. We're building all the key essential principles to really understanding the calculus. We haven't gotten to the calculus yet, okay? So we're building it brick by brick. So don't just forget everything you just learned. That's all. The reason that we did that was essential for calculus, okay? And likewise today. So remember that we were talking about constant rate of change, and we said that if two quantities have constant rate of change, what kind of graph relationship do they have? Linear, right? Okay, so can we try a mind exercise? Can you forget everything you've ever learned about lines and linear equations?
No. Probably not.
He said no. Right, and that's why I'm going to try though. Okay, so try to pretend you've never really learned about lines before, because this is going to feel really different. But this way of thinking about it is building on constant rate of change is going to really help us when we get to the calculus, okay? So pretend you never learned lines before, which means you don't know the formula what? Y equals mx plus b. You've never heard that before. And you're not going to try to use that, okay? You'll see. Okay, so really try to stay with me. And then Owen's going to continue this in recitation, and your homework for Monday will be to practice this new way of thinking about lines, okay? So here's the situation. Two painters have started painting their respective houses. At a certain point, the first painter, we'll call him P1, has already painted 250 square feet. The second painter has already painted 400 square feet. So the first question is, how could we use a horizontal bar diagram to illustrate this situation? Where's Jacob? Jacob A. Yeah, so how could we use a bar diagram to illustrate this? So what will the bars be like? Tell me exactly what they'll be like. Tell me exactly. Can you be more specific than almost double? Yeah, so one of the bars will be? Something like this? Okay, so the blue bar, can you see the vertical lines?
Yep.
Does the vertical lines show up, especially in the back? Okay, those are 100 each, kind of. Okay, so the blue bar represents the amount painted by which painter? Piece of cake, right? P2. The pink bar? P1, okay? All right, so, wow. So we're going to define it that way. So the total area painted by painter 1 in square feet is going to be the lower pink bar, and the total area painted by painter 2 is going to be the upper blue bar. Okay, so painter 1, the pink one, he's going to paint an additional 100 square feet. Okay? He's going to paint an additional 100 square feet. So my question is the total amount painted by painter 2 have the same relative size as the total amount painted by painter 1? So is there a relative size relationship, a constant relative size, of painter 2's total area painted versus painter 1's? Yes. What do you think? Some people are saying yes. So we know that when painter 1 had painted 250, P2 had painted 400. So is the total amount painted by P2 proportional to the total amount painted by P1? Well, he's saying no. What do we think? Yes or no? Yes. Nicole? Is the total amount painted maintaining a constant relative size? Nicole? Yes. Tell me your name again.
Mine?
Yeah.
Talia?
Talia.
I think that it is.
You think that it is? Okay. Well, let's take a look. So, we're going to say X is the total amount painted by painter 1, and Y is the total amount painted by painter 2. So when painter 1 had painted 250, painter 2 had painted how much? And now we have some new information. What new information do we have? Marcus?
He painted 100 more square feet.
So what's this total amount painted? See, these are total amounts painted. Total amounts painted.
The new total was 350. And
The new total is what?
350.
350? And?
That one's 525. Looks like.
Yep. Okay, now talk to someone next to you. Is the total amount painted, does it maintain relative size? Is it proportional? Talk to the person next to you. Where's Connor Simpson? Connor. Connor Simpson's not here. How about Lauren? Ryan? What do you think? Yes or no? Why? Why not? You got a feeling. Somebody new. Tell me your name here. Tell me your name again. Yeah. Andrew. What do you think? Is the relative size, we should know this, right? This is just a question right from test 1. Is the relative size of total amount painted maintained?
No.
Why not?
Because 400 over 250 is not the same as 525 over 350.
Right. Right. 400 over 250 is the relative size of the amount painted to start with, and now we have a new amount painted. The new relative size is 525 over 350. They're not equal. Remember, relative size is the ratio of two corresponding quantities. If that's changed, the relative size is not maintained, so they're not proportional. Did you come to that conclusion? You see that? Make sense? Okay.
And that's
So-
the same thing as saying because X went by 100 and that one by 125.
Yeah.
So therefore they're not. Is that the
We're
same?
asking about total, that we're comparing the total amounts painted. Total amount painted. The total amount painted by painter 1, we knew 250, and then 350, and the total amount, corresponding amount painted by painter 2, 400, and the corresponding 525.
Order for it to be corresponding should be like 560, correct? So
Whatever would make the ratio the same. Keep the ratio of y to x the same. So why might I have displayed this new amount painted as a thinner bar? What might that represent that we've talked about?
changing, changing.
Yeah, right? So this was like, this one is change in what? Change in y and change in x. What was the change in x? And what was the change in y? 125. How about the changes in the amount painted? So these are new quantities, right? These are the total amounts painted. These are changes in the amount painted. Is the additional amount painted by painter 2 proportional to the additional amount painted by painter 1? Kaiser, what do you think? You don't think so? Cindy? No? Tell me your name right here. Yeah. Is the additional amount painted by painter 1 proportional to the additional amount painted by painter 2? What was your name again? What's that? Okay. So yes or no, what do you think? Sharon? He said not enough information. Why not?
Because there's only one X value, one Y value.
Delta X, right? She's saying there's only one delta X value and only one delta Y value, so there's not enough to know if additional amounts are proportional. What do you think about that? Yeah, good. All right. So that was a harder question because it was you can't know yet. All right. So we're gonna have painter 1's gonna paint some more. Okay. Here we go. Oh, I almost had it on the first try. There we go. Got it. So what I want you to do is, so we said that this right here matched up with that right there. This was at 350. And this was at 425? 525. Thank you, 525. So now I just brought it out to here and to here. So now I want you to work with your partner, and I want you to get more ordered pairs, both of total amounts painted and changes painted. Okay? Get as many as you can, as many ordered pairs as you can of total amount painted and change in the amount painted. Work together, get as many as you can. I'm going to call on you in a minute. Okay, Christina. Is it Christina, right? Any ordered pair you want, either total amount of painter 1 and painter 2 or additional amount painted by painter 1 and painter 2. Give me one that you came up with. Did you see how we got 250 and 400? The original amount, that was the thicker bar, the original amount of each. And then what did I do? I increased the amount painted by painter 1 by 100, and how much did painter 2 go up?
450. So, 450. And then you can go 450 and
We're not, so you're saying here 450?
yeah.
We don't know where that goes though, right? So we don't have anything to connect that to, for sure. Let's say, for instance, we can connect, we know that this and this correspond.
Okay, so I think 200. I mean,
650, okay. And? What was it?
900.
Okay, do we agree with that?
Yes.
When painter 1 had 650 painted, painter 2 had 900 painted. Okay. Jatia, can we get any more of these? Total painted by painter 1 and painter 2. How did you get a change in X and a change in Y? Can you tell me one that you got?
300.
When painter 1 painted an additional 300,
And
375? So are you looking at from here to here? And then corresponding from there to there? What do we think?
Yes.
Did you have a different one? Is it Rohit?
Yeah.
You had that same one? Anyone come up with a different delta X and delta Y? Adonai? Sorry, you started talking, you started... So, Lauren, go ahead.
Okay. You can start from where the thick part is.
Okay.
X value. So that would be 400. 1, 2. Yeah, 400.
400 change in X,
And then the same thing for the top Y value.
which is how much?
500.
See where all these values came from? Comparing total amount painted, we got some corresponding values, and then additional amount painted by the painters. Okay, so what did we say? Is there a proportionality between total amount painted? Is the relative size maintained? No. Is there a proportionality between the changes or the additional amount painted?
Yes.
Okay, what is the relative size? What's the relative size?
4/5.
He said 4/5. How did you get that?
100 over 125 or 300 over 275.
Yeah, so we're going to do delta y over delta x.
Yes. If you like see. Oh yeah, and that was
5/4 or 1.25. Okay, so the additional amount painted by painter 2 is always 1.25 relative to what the additional amount painter 1 does, right? And that's consistent always. Is that right? So how can we then write what is the additional amount painted by any additional amount painted by painter 2? Any additional amount painted by painter 2? Elizabeth.
1.25 delta X.
Remember when we said this was going to be really important? So here it is. Every additional amount painted by painter 2 is always 1.25 the additional amount painted by painter 1. Or the change, right? The changes. Do we have that kind of thing for total amount, y equals kx? Is there some constant multiple that gives us the total amount painted for painter 2 given painter 1? No, right? Do we have constant rate of change? Do we have constant rate of change of total amount painted by painter 1 to total amount painted by painter 2? Do we have constant rate of change? Saying no. Nicole, you say yes? Why?
Because the 1.25, that change is always constant.
In order to have constant rate of change, what needs to be true? The changes need to be proportional. That's what we got. We've got the changes are proportional. Therefore, the total amount painted by painter 2 is in constant rate of change with the total amount painted by painter 1. Right? It's not that the total amounts are proportional, it's that the changes are proportional. That's what we've been working on with all those reflections. Okay? So we don't have proportionality of the total amount, but we do have constant rate of change because the changes are proportional. They maintain relative size to one another. And we can always find the additional amount painted by painter 2 by multiplying whatever painter 1 did times 1.25. Okay, so this number, 1.25, how else can we interpret it? So remember we talked on Wednesday, we had a list of all these different implications of constant rate of change. So far we've said, we've used 2 of them. We said that it's the relative size of changes in y to changes in x. It's the amount that we multiply any change in x by to get the corresponding change in y. What else? Lauren?
It's the amount, like, changes in y change 1.25 times as fast as changes in x.
Okay, kind of. What changes 1.25 times as fast as what? Yeah, the total amount. If we've got this, then the total amount painted by painter 2, he's painting 1.2 times as fast as painter 1. That's true. He's painting 1.2 times as fast as painter 1. Okay, what else is true? If we've got constant rate of change, what else is true about this 1.25 number?
And a linear relationship.
Okay, linear. All right, so we're going to have a linear. What's in a linear relationship? What quantities? X and y are linear, right? X and y are linear because the changes are proportional. And that's what we want to focus on today. The other thing is anytime painter, say, paints 300 additional square feet, what additional square feet will painter y paint? Yeah, so every time painter, you can pick any one of these, every time that painter 1 paints that additional amount, painter 2 will always paint his additional amount. That won't change. So equal changes in x will correspond to equal changes in y. Okay. So if we wanted to talk about slope, we're talking about lines. If we want to talk about slope, how do we need to kind of alter the diagram here to talk about slope? Remember this?
Y negative x.
We got to flip up which bar?
Y.
Okay, so let's take it back to the original amounts that we started with. Okay, so this point corresponds to total amount by painter 1 of how much?
400.
Painter 1? 250. Painter 2? 400. That's that point right there. Now I'm going to show this additional amount by painter 1 of 100. And we get a new amounts of totals. What's now the total amount painted by painter 1? 350. And what's the new amount painted by painter 2? 525. So how can we illustrate those changes? We had a change in painter 1's total amount. We had this change of 100, and painter 2 correspondingly painted an additional 125. How can we show those changes? What's that? Okay, but so, and then what, how could I show the changes here in the picture? Connect the dots. This shows the two changes? How do we show, just say just the change in X? Stanley, how do we show just the change in X?
Just the horizontal line.
Yeah, right there, right? That's the change in X, and that change in X is how much? 100. And the corresponding change in Y? Is 125. And where did that come from? 1.25 times the change in X, right? Okay, now I'm going to increase it from here. I'm going to increase it another painter 1, another 200. Or I'm going to try there. Oh, man. There we go. Okay. What was that change in X? How much did that? What was that change in X? 200. Corresponding change in Y? Would be 1.25 times 200, right? 350? 250. So I've got this change of X of 100, change of Y 125, and then I did a change of X of 200 and a change of the corresponding change in Y of 250. So remember, what is your formula for slope? Remember this? Well, what is y2 minus y1? What does that mean? Change in y. And what's the change in y over the change in x? That's our relative size, right? So the slope, this thing that you learned, slope, is really that constant ratio of the change in y and change in x, or the relative size of changes in y to changes in x. That's the 1.25. So if I want any change in y, how can I find? I'm going to increase painter 1's paint amount painted. How can I always find the change in y? How would I calculate it? 1.25 times the change in x. Okay, really important. And so then as we let the amount of painter 1 increase, we can track all the ordered pairs together. And if I do any change in x, how much is the corresponding change in y? Okay, so the relative size is maintained. Change in y is maintained, corresponding change in x. Or in other words, the slope is constant. The slope is constant at 1.25. Okay, so here's what I want to do. So ignore the numbers on the axes, okay? The lines are 100. Each line is 100. So this is 200, 400, etc. So we have our point here. What was our initial point? 250, 400. And here I am at x equals, let's call it 585. I'm just picking it off there. Okay, so suppose we want to know how much has painter 2 painted when x has painted 585. So we want to use our constant rate of change to find this out. So what we're asking for, if I'm asking how much has painter 2 painted when painter 1 has painted 585, then what are we asking about the situation? Like visually, what are we asking? Who said that? Adonijah said he wants to know the value of y at this point. Is that how much painter 2 has painted? Yeah. Okay. So we're interested in, we know this is the value of x is 585. We want to know what's the value of y. And we want to use this idea of constant rate of change in the changes to find that amount that he's painted. So what can we start with?
250 for 585.
Say, Nicole said finding how much x has changed. Exactly. Is that kind of what you're thinking?
Yeah, subtracting 250 from 585.
Yeah. So the first thing we want to do is figure out what was the additional amount painted by painter 1. Okay, so this process that I'm starting here, it seems like it's really hard for students to catch on to it. So we're going to do it several times, and then you're going to practice it in your homework. Okay, but this is the process that we want to use to really use this idea of changing quantities to think about linear relationships. Okay, what is the change in x? 585 minus 250, which is 335. So we know the change in x. So what can we easily find? Richard. So to find change in y, what is the change in y? 1.25 always times the change in x, right? That's the whole. So let's do that up here. This is the whole deal right here. If we have a linear relationship, changes in y are proportional to changes in x. And any change in y is going to be that constant times the change in x. So what is that? Say it again. 418.75. We're almost there. We're almost home free. So, what was our goal? Our goal was to know now painter 1 is painted 585. How much is painter 2 painted at that point? In the gray jacket there, tell me your name. Yep. Peter? So, how can we find then how much painter 2 has painted? Okay, we got the change in y. How'd you get that?
Since the delta y is 1.25 times that I multiply, excuse me, 585 by 1.25.
How can we show this on the graph? So how can we show that change on the graph? How can we show? Yeah?
Well, what I did is just take your original amount you had painted by y and then add that change. So then you get 1875.
So what I heard you say was that the new y is just the old y, what? Plus the change in y. It should make perfect sense, right? So we started at we started at 400, right? And then what did we do? Using proportionality of changes, we found out that the change in y was 418.75. So if our starting value of Painter 2 is 400, it went up 418.75. What's the new y? Square feet. So this is the process we want to understand. Start with a change in x. Use constant rate of change to get the corresponding change in y. Then you've got your starting y value, plus that change will be the final y. So what I want you to do now is, you try that for, say, 312. So if Painter how much has Painter 2 painted when Painter 1 painted 312 square feet? Okay? How much has Painter 2 painted when Painter 1 painted 312 square feet? So how much has Painter 2 painted when Painter 1 painted 312? Is Stephanie Sandoval here today? Stephanie? Still working on it?
Yes.
Okay, take another minute. You're going to be up in a second. Are you ready? Can you just get me started? Let's do it together. So, what did you do first?
I measured the change between the 312 and the 250.
Okay, good. So I'm going to show that like this, right here. So this red line right there is the change in x. And what did you find it to be?
62.
Agree with that? Cool. Then what?
And then since the change in y is 1.25 times the change in x, I just multiplied it by 1.25.
And we can show that right there, right? Is, she said, 1.25 times 62 equals?
77.5.
Keep going.
And then I added that to the 400.
And she wants to add the 77.5, the change in y, to the original y. And what do you got? So what ordered pair is that right there? 312 and? And what does that ordered pair represent? Tell me your name again.
Dan?
Dan. So this ordered pair, 312, 477.5. That's an ordered pair. What does it represent?
It's 477.5 over 312 is 1.5. The change, the rate of change.
So you're saying the ratio of this over this is 1.25?
No, it's not.
So all I'm asking is, what does that ordered pair, what does it represent in the situation? In the whole context, what does that pair of numbers mean?
The total change.
The total change.
Yeah,
Corey.
when painter X has painted 312 square feet, painter Y, or painter 2 has painted 477.
When painter 1 painted 312, painter 2 painted 477.5. Right? Square feet. Okay. So now we want to kind of do the same process so that we can have, instead of having to do it over and over again for every amount that we pick for painter 1, can we just come up with a general formula that will do it for us every time? But to make the general formula, we're going to do it one more time. Okay? So now just consider this to be any x value here. So this is any x right here. Any amount painted by painter 1. Our goal is to find the corresponding amount painted by painter 2. Same process. How do we start? Amos.
Sorry, I kind of dozed off. I had no sleep last night.
Okay.
What was-
So we're going to go through the same process again, but instead of actually picking a value of x, we're just going to say let it be any x. Let it be any amount that we are going to start with.
Well, first we found the change from the original value to the new value of x, so
What would that be?
x minus 2.
Pretty good for low sleep. Right? Okay. How do you do? X minus 250. Is it Adelaide?
Yeah.
Then what are we going to do next?
For the change in y, it's going to be y, well, the quantity of y minus the original y quantity, which is 400.
Okay, but we don't know what that is, right?
Yeah.
So instead, what's a different way we can write what delta y is? Using constant rate of change.
Well, I guess we're trying to find x.
You're just trying to write what delta y is using constant rate of change. So given our change in x, how much is the change in y?
Well, y is 1.25 larger than x.
Careful. So what's 1.25 times larger?
That's the constant rate of change, so the amount is different.
But is y 1.25 times greater than x?
X
Change in y, right?
Yeah.
Rohit.
Delta y is 1.25 times greater than delta x, but it's needed to be 1.25 times the quantity of greater than
That's right. Given any change in x, in this relationship, we know exactly what the change in y is. It's that constant multiple times the change in y. Okay? Last step. Who hasn't had a chance yet? Cindy. So now we're ready to write what y is, right? What is y? What's that?
Is it just 1.25 times the x minus?
So what did we do? We were here, and we changed x this much, and we got a corresponding change in y of this much. So how do we find the new value of y?
The y value plus
What is the y value? Yeah. 400. Old y value plus? How much it changed? Okay, so now we don't, so by deriving this formula, we don't have to go through it every time. So we can just do it one time with any arbitrary x. And so now we can use this formula. So when painter 1's painted 900 square feet, what do we do? Plug in 900. What does 900 minus 250 represent? Change in x. Find the corresponding change in y for that. What is it?
587.
Someone agree with that?
Yes.
Okay. So by plugging the number in, it's like doing the calculation. You're walking through the process again, right? Change in x, change in y, add the original y. Okay, so one more time. This time, I want you to start again from here. I want you to find how much had painter 2 painted when painter 1 started. So same process. How much had painter 2 painted, starting with 250, 400. How much had painter 2 painted when painter 1 started? Go. You can work together.
Say it again.
How much had painter 2 painted when painter 1 began? When painter 1 had painted nothing. Go through the process again.
Which one is painter 1, painter 2?
X is painter 1.
So when x was 0 is 250. So you just plug 0. X minus y.
It's negative 250. I just put in 0. It doesn't so 0.
It's not an
What's the change in x?
Negative 2. Negative 12.5.
Change in x.
0.
Nope, the change in x. The change in x. Some of you are saying negative 250, right? Change in y. Always. Changes in y are always this number times the change in x. Equals?
Negative 312.5.
New value of y. Old value plus the change. $87.5? Or how could we have used this formula to do that same thing? Just plug in 0 for x, right? That's what we're saying. We're saying we want to know how much painter 2 had painted when painter 1 had started, or painted 0. Plug in 0 for x. You end up doing the same thing with that formula that you just did there. Okay, so instead of y equals mx plus b, now we're talking about, where can I put this here? I'm going to start over. Can I erase? What are we saying? we're saying y equals a starting value of y plus our relative size of the changes times x minus our starting value of x. So this is x1, y1 is a known ordered pair, and k is
Constant rate of change.
the slope or the constant rate of change or the relative size of the changes. So you're going to, in recitation today, you're going to practice, Owen will demonstrate some more, and then you'll have your homework. He'll give you your homework for Friday as the handout. On Monday, you're not going to turn in that sheet that he gives you. You're not turning that in. You're going to do all your work on separate paper. There's not enough room to do your work. So just hold on to the sheets, do all your work on separate paper. You're going to hand that in Monday for homework. Okay? Have a good weekend.